welcome back. This is section P6, complex numbers. What we're going to do in this section is we're going to talk about the situation where we have equations that we solve that have answers that are radicals with negatives underneath them. So for example, when we look at this one, if I work on this one to try to extract square roots, and I subtract 1 from both sides, and I end up with x squared is equal to -1, and if I take the square root of both sides, I end up with x is equal to the plus or minus the square root of -1. This is not possible. Okay, this is what we call an imaginary number. Imaginary units are when we have the square root of a -1 and it's equal to the imaginary unit I. And so what that allows us to do is, like if we have a negative square root, we can factor out a -1 and then deal with the other number part of the square root by itself. An important note on here is I squared is actually equal to -1, the square root of -1 squared, which is equal to -1. That's going to be important going forward. As we deal with complex numbers have a real part and an imaginary part. A plus bi is the standard form, where a is the real part and bi is the imaginary part. So those two parts together make up the standard form of a complex number. To add complex numbers, I'm simply going to add the real parts and I'll add the imaginary parts. And so my answer is the real part plus the imaginary part. Subtraction works the same way. I'll subtract the real parts, and with that, I'll put the difference of the imaginary parts. So -6 minus 4i. Multiplication works as if I is a variable. Okay, so it works as if I is a variable. So as I distribute here, I get 10 minus 2i plus 15i minus 3i squared. The note up here that we had where I squared is -1 comes in handy here because we realize we don't have an I squared. We actually have a -1. So it's 10 plus 13i minus 3 times -1, which is 10 plus 13i plus 3. So my complex number is 13 plus 13i. In this next example, we need to cube z, where z is this pretty complex number. If you get confused, remember that this is what this means. To cube something means to use it as a factor 3 times. And so when I use it as a factor twice, I end up with 1/4, 1/2 times 1/2. I end up with root 3 over 4i. I end up with plus root 3 over 4i. And I end up with a root 3 over 2 squared, I squared, for my first two terms. Let's do a little bit of simplification. 1/4 is fully simplified. If I have two of these, so I essentially have 2 times root 3 over 4i. And this one back here, a root 3 over 2 squared would be 3 over 4. Because root 3 times root 3 is 3. 2 times 2 is 4. Times an I squared would be times a -1. And so if I reduce this middle fraction to 1 over 2, I end up with 1/4 plus root 3 over 2 I minus 3/4. When I simplify 1/4 minus 3/4, I've got minus 1/2 plus root 3 over 2i. I've used it as a factor twice now, so I need to multiply that by my remaining factor, 1/2 plus root 3 over 2i. When I do this, a cool principle is going to be illustrated here. So I've got -1/2 times 1/2 would be -1/4. I've got a -1/2 times root 3 over 2 times I. I've got a positive root 3 over 2 times a half. So 1/2 times root 3 over 2 times I. And then I've got this plus, and I'm running to the edge here, root 3 over 2 squared, I squared. Well, look at what happened there. This is a positive term. This is a negative term. Minus 1/2 root 3 over 2 times I. This is a positive 1/2 root 3 over 2I. These cancel out. I've got the negative and the positive. They cancel out. So the middles cancel out. And so what I actually am left with is a minus 1/4 plus, and this root 3 over 2 squared would be 3, because root 3 times root 3 squared. So root 3 times root 3 would be 3, and 2 times 2 would be 4, times negative 1, because that's I squared. So I essentially have negative 1/4 minus 3/4, which gives me negative 1, which is my answer. So a lot of work on the front end, but what we see is a really cool principle illustrated here, where we have the plus minus situation, meaning x minus 1, x plus 1, those middle terms are going to cancel out. That's what we're doing when we talk about complex numbers in standard form and using division. The complex conjugate of a plus bi is a minus bi. And so when we divide, we're going to multiply the top and the bottom by the complex conjugate of the denominator. To put this in standard form, we're going to multiply by 3 plus I over 3 plus I, because the complex conjugate of the bottom is 3 plus I. So what I'm left with is 6 plus 2I over 9. So 3 times 3 is 9. 3 times I would be 3I. Minus I times 3 would be minus 3I. Minus I times I would be minus I squared. If I simplify this, I've got 6 plus 2I on top. On the bottom, I've got 9. These cancel out. Minus I squared would be minus a minus 1, so plus 1. So I've got 6 plus 2I over 10, which is equal to 3/5 plus 1/5 I. That's my answer. Real part, imaginary part. Simplified and separated. In an example like this, I'm still going to multiply by the complex conjugate of the denominator. And so that's going to be 2 plus 3I. Well, what you're going to see is I'm going to have a complex number on top. On top, I'm going to have 10, so 5 times 2 is 10. 5 times 3I would be plus 15I. I times 2 would be plus 2I. And then I times 3I would be plus 3I squared. On the bottom, I'm going to have 2 times 2 is 4. 2 times 3I would be 6I. Minus 3 times 2 would be minus 6I. Minus 3 times 3I would be minus 9I squared. Let's clean this up a bit. On top, 10 plus 17I. And this is 3 times minus 1, so minus 3 is going to be equal to 7 plus 17I. And on the bottom, I'm going to have 4, these cancel out, minus 9I squared, so I squared is negative 1, so 4 plus 9 is 13. So my answer is 7 over 13 plus 17 over 13I. That's using the complex conjugate to multiply the top and the bottom and get that complex number out of the bottom. The quadratics connection is this. When we look to solve this problem, so before we fill in this space here, let's look to solve this problem. If I've got x squared plus x plus 1, and I go to use my asterisk method, my top is going to be 1. My bottom is going to be 1. I'm going to have a 1 and a 1, and then I'm going to have things that multiply to 1 and add to 1. And so I realized pretty quickly here that I can't use factoring. And so if I can't use factoring, I've got to go to my next possible form, and that's to use the quadratic formula. I'm equal to 0, so I'm going to have negative 1 plus or minus the square root of b squared, which is 1 squared, minus 4 times 1, which is a, times c, which is 1, over 2a. When I simplify this, I have negative 1 plus or minus the square root of 1 minus 4, so negative 3 over 2. Well, look at what happens here. I have two possible solutions. I've got negative 1 plus negative root 3 over 2, and negative 1 minus root 3 over 2. Well, I can't keep this radical like this. I can't keep a negative under there. And so I'm going to simplify this to say negative 1 plus root 3 times root negative 1 over 2, comma, negative 1 minus, this should be a negative. You probably caught that already. Minus negative 1 times root 3 over 2. When I simplify this, it's going to be equal to negative 1 plus root 3I over 2, comma, negative 1 minus root 3I over 2. And so I can rewrite my answer as negative 1 plus or minus root 3I over 2. The quadratics connection is this. What you notice is, on the inside of this, this is called the discriminant. That's the b squared minus 4ac. If b squared minus 4ac is negative, okay, so it was negative here, we're going to have two complex solutions. And notice, they are conjugates of one another. So it's the real part plus the imaginary part, the real part minus the imaginary part. So the two complex solutions are a complex conjugate. If they are positive. So if the discriminant, if b squared minus 4ac is positive, then we're going to have two real solutions. If the discriminant is 0, we have one solution. And it's real. Okay, because we would have, like, for example, if the discriminant is 0, we'd have negative 1 plus 0 over 2. Well, plus or minus 0 is the same thing, so we have one real solution. The quadratics connection is this. We can look at the discriminant, b squared minus 4ac, and see if it's negative, we're going to have two complex solutions. They're a conjugate pair. If it's positive, we're going to have two real solutions. If it's 0, we're going to have one real solution. All right, guys, thanks for watching, and we'll see you next time.